Okay, so my question is, how does isolating barbital from urine work using C18 silica? So, the first thing I want to talk about is the concept of solid phase extraction, which is what they use to isolate barbital. So in solid phase extraction, there is a mobile phase, which can be polar, nonpolar, or mixture. It all depends on what you're trying to isolate. And then there could be an immobile phase, which is, there's a couple different options, but the one that we're using for this problem is C18 silica gel, which is that structure right there, and it's highly nonpolar. And the mobile phase and immobile phase depend on what you're trying to extract. So it all depends on that good, awesome stuff. And this is a structure for barbital, and it's super polar. Well, not super polar, but it's polar. So we're going to use a polar mobile phase so then we can elute out the barbital that we need. So the answer, the first step, is you take a syringe filled with C18 silica. That's going to look something like this. Silica. Awesome. So we take a syringe with that, and then we add a bit of methanol, and that just removes any not wanted organic material that was already present in the silica, so we just get pure silica. All we need is all we want. So you can also do it in column chromatography, which is what organic chemists use. It's me. It's awesome. And all that is just way more silica. But so to determine how much silica you need, it's roughly around 1/10 the molecular weight of the product that you're trying to extract. So, number 2, you wash with the mobile phase. So the mobile phase, it can be polar, nonpolar, the mixture, like I said earlier, but it helps if you use it and it matches what you're trying to extract. So in this case, we're trying to extract a polar molecule, so we're going to try and use a polar mobile phase. Usually for polar, water is good, but for this one, we use 1-to-1 ratio of acetone and chloroform. And we do that because that's what the book said. So that's what's going to happen. But usually chloroform is there to just maintain a intermediate form of polarity. So like if you wanted to change your elution solvent, you would keep this with the 1 and you would just change the acetone ratio. So then 3, we add the urine sample to the top of the silica gel. And when you do column chromatography, you add a light layer of sand to the top, and this always ensures that your given sample is wet, and that just causes better elution. So we throw urine sample here, awesome sand there. All right, we're good. So, and then 4, we run a mobile phase through our column or a syringe. And this is going to elute the polar substance first, because the polar substances are going to interact with a 1-to-1 acetone chloroform, while the nonpolar substance are going to react with our C18 silica gel into super nonpolar. And so, how do we know when to stop? Usually, before we do this, we run TLCs to know where the product is that we're trying to isolate. So then we can use, like for example, in one lab, since fluorescein elutes slower than the product that I want to get, once fluoresceine's at the bottom, then we know all the product that I need is already out. And so then when we do this, as we're running our mobile phase through and it's dripping down, we collect different fractions. So we're going to have a bunch of test tubes, and then we're going to drip fractions in there, and we're just going to keep collecting various fractions. And then we can analyze these fractions to see if our given product is there, normally through TLC, and like I said, we compare it to the TLC that we usually did before the experiment. And so, some good questions. How do we change it so we want a nonpolar product? Well, we could use a polar gel, just like regular silica, and then we can use a nonpolar mobile phase, like a hexane ethyl acetate solution. And then, so essentially what we do is we use equilibrium to our advantage, and then we gradually increase the nonpolarity of the solvent to get the more polar substances out, or we decrease it to get the polar substances out. And then columns take a super long time, and that's why people don't like them, so how do we speed it up? So we can adjust polarities to increase speed. So depending on the TLCs that we ran to begin with, we could adjust the polarity to make it, if we know that something elutes at a semi-polar level, we can make things super polar, so then everything just runs through super fast. But then for that, it's best to collect smaller fractions so we can isolate our product better.
Hugo going Cocoa.